Okay, so we have a 2016 F-150 with a complaint of a check engine light on and vehicle runs rough. There's our VIN number for the task sheet. And there's our miles, 120,733. We're going to verify that the engine does in fact run rough. Okay, we're going to verify that the engine does in fact run rough, which we can kind of feel it in the steering wheel. But with an open door, you can really see it shaking. Hopefully you can verify that. There's a really good picture of it shaking at the door. We can also feel it in the seat. Important to make sure that we verify the customer's complaint. It's important that we verify that the engine's actually running rough and not just vibrating. So we're going to bring out our trusty, Jackson, and we're going to check the tailpipe with a dollar bill test that we've been taught to do. And we can verify that if the dollar bill wouldn't quit curling up on me here, that the engine's running with a misfire. We can also see some vibration up here in the engine room. We can also hear a tick in the engine that we want to see if that's related to the complaint at all. Okay, so we booted up our IDS system. This is Ford's diagnostic system to the car. So now we're going to perform a key on engine off self-test. So we're going to pick the toolbox, pick the self-test, powertrain, and we want to do a key on engine off test. And here it goes. And here we go. Here are our test results. We have a variety of codes that are going to be related to turbo failures, but the one we're really going to be concerned with here is our P0303. There's a cylinder misfire code. We'll address all the rest of those as we go on. Many of them are going to be caused because of the failure that we have with the engine. So let's do a couple other tests to see what's going on with this thing. We also have an engine over temp code. We have engine overspeed condition, turbo underboost condition, misfire when the engine first starts up, catalytic converter on the right side code, catalytic converter efficiency on the left side code, a crankcase ventilation system disconnected code, and crankcase pressure sensor performance code. So great number of these codes can be related to each other, so we want to kind of address what's going on with it. So we're going to come back to our toolbox up here. We're going to pick powertrain, and we can do a power balance test, and we're going to see what this car can do, how it's running. And we're going to see that as soon as it comes online here, cylinder 3 is underproducing by what looks like about 50 RPMs below what everything else is shooting at. So how this particular power balance is working is it's just we're watching crankshaft rotation. Each cylinder, as it fires, it turns the crankshaft to a certain speed, and as it rotates around and cylinder 3 is underproducing, it's like we may have some issues here with cylinder 4. Sometimes those one can relate to another, so we kind of want to go through here and see what's going on. Next thing I want to try to do is get a relative compression in, and that's just going to check the cylinders compared to each other. The computer's going to do a cranking test on it. We'll just hold it at wide open throttle, and when it tells us to, we just crank the engine over. We can hear that we have a compression issue on the car. If you can hear that or not. And it's going to give us our results, and it's going to tell us that cylinder 3 is in fact 3% lower than the other cylinders. And that's all based on crankshaft revolution, or speed. And so we're going to then take those information and decide what we're going to do. Probably do a manual compression test on that cylinder and find out what's going on with it. Alright, so I've come out here to cylinder 3. I've pulled the coil off, and I'm now pulling the spark plug out. And we're going to take a look at the spark plug and see what story it wants to tell us. And it's not eating up or anything like that. I'm not sure if you can see that. Let me see if I can get some light on it. It's just wet. So I don't think we have a problem of something destroyed that cylinder, but we're going to find out with a compression test. Okay, so we're going to choose the correct tool for the job, and we'll come back here and thread it in. We'll come on here and hook our compression tester up, and voila. Get a reading here. Okay, so we pulled the starter motor relay out of here and hook up our handy dandy starter button. I'm gonna try to set this gauge up here so you can watch it. We'll hit it on the first hit like we've been taught to do. Okay, so we did the first mistake of the world is we had the key on. We tried to do a compression test, which isn't the end of the world, but let's try this again. Okay, and we look at our test results here, and we didn't even have a good first hit. We have like less than 20 pounds of compression, so we know that we have a cylinder with a really bad hole in it. So let's see what we're going to do next. So now what we're going to do is do what we call a cylinder leakage test. Okay, we're going to have our cylinder leakage tester here, and what this is going to do is tell us the percentage of leakage in that cylinder and where it's kind of going, so we can listen to the cylinder and find out, or listen to the intake manifold, listen to the exhaust manifold, listen to the crankcase, and determine where that air is going out to. So I'm going to stop you here for a second so I can do this because I'm only one-handed, and we're going to hook up the line to this. Okay, so it's important that this has just gone into the spark plug hole. We have the cylinder at top dead center, compression stroke, so the valves are theoretically closed. So the valves are closed, and we are sending air into the cylinder right now, and we show that we have about 90% leakage in that cylinder. So either we have a valve stuck open, an intake valve, or an exhaust valve, depending on where it's going. We could either listen to it out the exhaust, or out the intake manifold, or out the crankcase. So let's, I think logically with what we're looking at here right now, I think we're going to check the crankcase. So we can pull the oil cap. As we pull the oil cap, and we see the smoke coming out of the oil cap. So I think we're pretty safe to assume that we've got some sort of a melted piston, a burnt piston, cracked piston. I would almost think that, you know, we got a melted piston based on the knocking noise that we're hearing in this motor. But we'll find out here, see if we can't get a bore scope in here and take a look and see what's going on with that piston. Okay, so now I put a bore scope in the cylinder, and I could see that the valves were closed, and looking down on top of the piston, I couldn't really see anything obvious. But if you look at this is looking at the cylinder wall, and you can tell, you can see in here that this is all oil that's running into that cylinder, and you can see that on the side of the cylinder there, how scraped up that cylinder wall is right there. Let me see if I turn it around here. we can maybe see some smoother part. Well, I've turned it around to the other side of the cylinder trying to find something in there that's any good, but it looks like that cylinder is just chewed up, like it's has piston's probably broken. Based on the sound that we're hearing, that cylinder's the piston's probably broken, or the skirt's just fully collapsed on it and melted. So we can pretty much assume that the only way we're going to fix this thing is with a long block. That many miles, I wouldn't attempt to do a short block on it at all, and that cylinder's not savable. So